This lesson we're looking at bearings. So remember, the bearings, we've got two different types. We've got our compass bearings, we've got our true bearings. So compass bearings always start with either north or south. So it'll be north or south first. Then they have the degrees away from north or the degrees away from south. So it could be north 20 degrees or south 20 degrees, and then it'll be either east or west to finish. So it could be north 20 degrees west or south 20 degrees east. And that means, so for the first one, north 20 degrees west, from north we've moved 20 degrees to the west. South 20 degrees east, well actually the example we've got here is south 70 degrees east. It means from south we've moved 70 degrees to the east. Now a true bearing, it's always got three numbers, 1, 2, 3, and it starts at north. So it starts at 0 north and it goes around. So the first one, 30, has moved 30 degrees from north. If we go here, 90 has moved 90 degrees from north. 110 is 110 degrees from north. 180 is obviously 180. 225 is 225 degrees from north. 270 is 270 degrees from north. 340 is 340 degrees from north. So it's always from north around clockwise. All right, example 5. A ship is sailing on a bearing of 163 degrees true for 150 kilometers. How far east will it be of its starting point? So this is a true bearing. So we're going to draw our compass. Put our north. Now think about it. If we've got our compass, and we're doing true bearings, we've got 0, 0, 0 here. This is 90, 0, 9, 0, and this is 180. So 163 is going to be coming out down here somewhere between 90 and 180. So that angle there is 163 degrees. Okay, and it says it sails for 150 kilometers. So we'll get green. That there is 150 kilometers. The line. We want to know how far east it is from its starting point. So how far in an easterly direction has it traveled? So if it started here, how far directly east did it travel? So we're looking to find, my diagram's getting a bit messy, but we're looking to find this blue distance here, which we'll call x. Now to do that, we need to make a triangle. So if I draw a dotted line down here, we've got a little right angle triangle. Now I'll redraw the triangle over here. I always like to redraw my triangle and only add the information that's needed. So we've got 150 here. Now we don't actually have any angles in our triangle. We've got that from north all the way around the line is 163. However, we only want the angle inside the triangle, the blue angle. So I know that I've got 90 degrees up here. So if I do 163, take away, actually I should probably do this on the line. If I do 163, take away 90, I'm left with 73 degrees, and that is the angle inside my triangle, 73 degrees. And I'm trying to figure out how far east it is, so I'm trying to figure out how far it's moved across east, which is our x up here. Now, we have a triangle, we have a side, a missing side, and an angle. We can use trigonometry to solve. So if we're labeling our sides, we have our hypotenuse and our adjacent side, which means it's going to be cos. Cos of theta, or 73 degrees, equals a, which is x, over h, which is 150. From here, we multiply by 150. So we get x equals 150 cos 73. We put that in the calculator to calculate x. And we get 43.8 6 meters. So we draw a diagram, we find a right angle triangle, we find the information on our right angle triangle, we use trigonometry. All right, let's have a look at the next one. The diagram shows the position of Q, R, and T relative to P in the diagram. So we've got some information up here. I'll highlight it as we go. Q is south of P. R is northwest of P. And angle QPT is 165 degrees. So let's have a look at that. Q is southwest of P. Now, southwest of P means exactly southwest. So if we were to think south is down here, west is over here, it's exactly halfway between the two. So if this is 180 and this is 270, it's a terrible 7, 270, that is an extra 45 degrees in there, and that's 45 degrees in there. So the true bearing of Q would be 225. What else does it say? R is northwest of P. So that there is 45 as well, which means there's a right angle in there. And if Q is 225, if we add 90 to that, R is 315. And angle QPT is 165, that's already on our diagram. So it says, what is the bearing of T from P? So of T, here, from P, we're trying to find this thing here. So it says from P, we start at P, and we're going to T. Now, if it doesn't classify whether it wants a true bearing or a compass bearing, always assume true bearing, okay? Always assume true bearing. Don't ever go, oh, I'll write a compass bearing. We'll go true, especially if the question has a true bearing in it of 165 degrees. They don't write the T anymore. The T is old school. They used to write T on the end, 165 degrees T. Now they just write 165 degrees. So always assume true bearing. Okay, to find that, we have pretty much every other bit of information in the circle that I've written down already. The other thing we know that I haven't written down is that this here is also 45 degrees, isn't it? We know that's 45 degrees because point R is exactly northwest. So it's 45 degrees from north and 45 degrees from west. So the information we do need is that all the way around a circle is 360 degrees. And we want to take off all of the bits that we have. So we're left with this angle here, theta. So right, theta equals 360. And we're going to take off, I'm going to highlight the angles we're going to take off. So we're going to take off this 45 here. So minus 45. We're going to take off this 45 here. Minus 45. Now obviously we could do 90s, but 45 will do. We're going to take off, what other color? Orange. This 45 degrees here. So we've taken off 3 45s, and then in one big go we'll take off all of this 165. Sorry about the background noise, guys. I've got construction happening next door. So theta is 360. I'm going to put it in the calculator. 360 minus 45, minus 45, minus 45, minus 165, and we get 60 degrees. So the bearing of T from P, therefore the bearing is 6, oh, hang on, when we write bearings, we write 3-figure bearings, don't we? 0, 6, 0 degrees.